Hi there, this is Mr. Sand, and we're going to talk about naming ionic bonds, and specifically the crisscross applesauce video. Uh, Today, we'll start off by just doing the easy step first, which is to take a formula, which is the symbols of an ionic bond, and change it into a name. So we've got formula going to name. Okay. And over here, I'm going to do some other kind of examples. So this is really easy going from formula to name. Let's see here. I have to do this just from memory. Let's see. Let's do this. Now, to figure out what the name of this compound is, ionic compound is, you take a look at this element right here. You look it up on the periodic table. If you look at the periodic table, you see, boom, this. So sodium. Sorry, Na. I just think of it as sodium now. Na is right here. Na is sodium. So that's what you write right here. You write down sodium for the first element. It doesn't change at all. You can use lowercase or capital. The proper way to do it is without any capitalization. So I'm just going to use sodium. And now we look at this second element, which is right here. That second element is O. You might know what O is. O is oxygen. There it is. So to write this in a name format, you replace the suffix oxygen with IDE. So it's sodium oxide is the name of this formula right here. Okay, let's do another problem. Let's choose, I gotta look at this real quick here. Let's look at this. Let's do Ca, Cl, that's an L, 2. Okay, so you look at this first element, and that does not change. You look up where Ca is. Okay, so Ca, and notice that all of these starting elements are always going to be on the left-hand side of the periodic table, and the non-metals are going to be over on the right-hand side of the periodic table. So we look at, I should get this out of the way. Okay, so we've got calcium right here, and we've got chlorine over there. That's Cl. It's not Ci, it's C lowercase l. Okay, so this is going to be calcium. And then the suffix is IDE, chloride. Now, if we want to do a, let's do a name to formula. So if you're given this name, I'll just do a name right here. Let's do magnesium oxide. How do you write the formula? That's the question. How do you write the formula? Well, I'm going to use a space over here to write this out. The symbols are Mg, you look this up in the periodic table, Mg and O. Okay. For Mg, look over here, it's in the second group. So that means that it has two, it's going to give away 2 electrons. I'm going to use a different color for this. It's going to give 2. Gives 2. It gives 2. Oxygen's over here. And oxygen is in the 16th, or if you just skip over the transition metals here, oxygen is going to need just 2 more electrons to get a full octet. So it has 6 valence electrons. It needs just 2 more. And it says, this is nice right here, it tells you how many valence electrons it has. So it's 6 right there, fluorine 7. All of these right here, you can see, all in this group right here, it has 6, it needs 2 more. That's 6, that's 6, that's 6. It needs 2 more electrons to get its full valence electrons. So oxygen is going to take 2. It takes 2. So this one's given 2, and this is taking 2. Taking 2 of what? Electrons, that is. So we're going to use a crisscross applesauce method right now, which means that I'm going to crisscross. So this is going to be a 2 here, and that's going to be a 2 there. So it's going to be Mg2O2, and if we simplify that, it's just going to be MgO. And that is our formula. All right, that should have been pretty easy for you. So this is going to be MgO. Or OMG. Right. Let's do another one. A little bit more difficult one. Let's do... Oh, this is going to be kind of tricky. Yeah, let's make it tricky. Let's do calcium nitride. Calcium nitride. Calcium nitride. So you're going to have Ca and you're going to have N. Can. Okay, where are these elements? So Ca is right over here, is in the second group, so it's going to be giving 2. So write that on top, gives 2. And nitrogen is over here. It's in the 5th group, or the 15th group. And it's going to take 1, 2, 3 electrons to fill its valence shell. So I'm going to write on top of that, takes 3. So if we crisscross applesauce, it's going to be 3, and that's going to be 2. And you can't reduce that anymore, so it's Ca3, N2. That's the proper formula for calcium nitride. It could not be anything else. Now, I can show you what this really means here. So calcium has 2 electrons, 1, 2 valence electrons, and nitrogen has 1, 2, 3, 4, 5. And you can think of them as having like holes over here. It wants 3 more electrons to complete its valence shell. And these calcium wants to get rid of these. It's more likely to get rid of these electrons. So if you get rid of these electrons, I'm going to draw a lot of arrows here, so bear with me. Calcium is going to get rid of both of these electrons. That's going to go there and there, but there's an extra hole right here. So the only other atom that can fill this, if you've got calcium and nitrogen together, is another calcium. So another calcium's around. Great. So it has 2 electrons to give. That's perfect. Those 2 electrons, I'll use a different color now, those 2 electrons can, well, one of them can fill right here into that hole. So now nitrogen's perfectly satisfied. It's got all the electrons it needs, but we've got 1 extra for calcium. So calcium now needs to get rid of that 1 electron for it to be fully, and it's fully, like the valence shell underneath of this shell, completely full. He wants to get rid of that extra electron. So the only atom around that can soak up more electrons is a nitrogen. So here's another nitrogen with its 5 valence electrons and its 3 holes where it wants electrons. So this calcium can give its extra electron right here to that nitrogen. But now you see another problem. Oh my God, these are 2 holes for nitrogen. Nitrogen needs to have those holes filled, and it can fill it by another calcium. That's the only other atom that can do that. So here's another calcium, and it's got 2, and oh, great, it's going to line up perfectly now, because now these 2 electrons, they can fill in these holes for nitrogen, and now everybody's satisfied. We've got a nice full valence electrons for nitrogen, both of these nitrogens, and these 1, 2, 3 calcium atoms. They're fully satisfied because they've given away their 2 electrons. So we've got 3 calcium, 1, 2, 3, and there's 2 nitrogens. So this is a more visual way of showing this process, but this is a way that will always work the crisscross applesauce method. Right. So that's how you do that. I'm going to make another video showing you the transition metals, because those can get kind of tricky. So stay tuned for that. Okay, bye.